This is Brian Carlton for ABN Newswire. Linc Energy Limited, ASX LNC, is a leader in underground coal gasification. They produce a synthetic gas which can be used either for power generation or turned back into a liquid for synthetic fuel production. The company objective is to commercialise underground coal gasification first in South Australia. It's very exciting stuff, and we're here at a Limelight Series cocktail event at the Sir Stamford at Circular Quay. Very pleasant. CEO and recent TV star Peter Bond joins me now. The technology first. What is underground coal gasification?
Underground coal gasification is where you literally are gasifying coal beneath the surface. So we concentrate on stranded coal. That's coal that's roughly more than 200 metres in depth. More than, say, 3 hours from a marketplace. So it's not where most people are going to mine it. It's coal that won't, in our generation, be exploited or probably forever. What we do is what is gasification is a great question, because gasification
was my next question.
It's just a lump. If you take a lump of coal, it's been around 200 years or more than that actually. Took a lump of coal, you put it in a box, you heated the box up to 1200 degrees centigrade. In the absence of atmosphere, you're just in a box. What would happen is that solid coal would turn into a gas. The fixed carbon would turn to carbon monoxide, the water would turn to hydrogen, and so on. And it's just a standard solid to gaseous state, standard physics and chemistry. What you need for that is you need a high carbon environment, closed, confined space, high temperature, 1200 degrees. And you need to just put a bit of oxygen down, a bit of air to make sure that all happens the way you need to, but away from atmosphere. So the perfect place to do that is underground, where you can create a cavity, the size of this room. You literally, it's glowing red hot. It's 1200 degrees centigrade. And what happens is in a confined space, you put a well down, 2 wells. You're getting the gasification process going. It consumes the coal, and the gas comes out the second well. And
now, crucially, you're not burning the coal, are you?
You're not burning the coal. You're gasifying the coal.
Okay, so it's a chemical process.
It's a chemical. It's basically a chemical physical reaction. But you're left to void. There is no coal left. It's like coal mining without the effort or without the environmental issues.
Obviously, you're not digging massive holes in the surface. That's got to be a benefit.
No, you're not. It's environmentally, you're miles ahead. All you've got is a series of wells, probably half a dozen or so wells, with a pipe running down to your commercial application, power station or gas to liquids plant. And on the surface, you've just got a series of wells. You've got no mining, you've got no stockpiles, you've got no dust, you've got no emissions. It's a very, very clean way of doing it.
And let's talk about the gas to liquid technology, because the resulting processes here sort of dovetail off into two areas. One's using the gas, another is converting the gas back into a liquid for use in things like diesel fuels. Yep. How does that process work? Well,
they're two different processes. You have the taking of the coal and making it into gas, where it's coming up out of the pipe, and then you can do various things with it. So that's the first process, making the gas and cheap gas. So we like to coin, we own a lot of acreage. We own billions of tonnes of coal in Australia and North America, and that's a large part of the company's business plan. And the fact that we control billions of tonnes at a cost-effective price means that we can convert that coal into cheap gas in a very cost-effective way. So you're talking about $1.50 per gigajoule gas, which is very cheap synthetic gas.
Wow, okay.
That gas coming out of a pipe at that sort of price in your backyard is a huge economic advantage. Taking that gas and then turning it into liquids is basically run it through what's called a Fischer-Tropsch plant, which the South Africans have been using for 55 years. And all it is a reactor that's full of catalyst. You pump the gas through the catalyst, and the catalyst joins all the carbon chains in a row, starts at the top. By the time it gets to the bottom, it turns into a liquid. So you're turning the gas back into a liquid by doing that.
Now, it's a very pure process, isn't it? The resulting, say, diesel fuel doesn't contain the impurities that normal diesel fuel contains, and therefore burns cleaner, more efficiently, more environmentally friendly?
Absolutely. So it's a bit like synthetic oil, which is obviously a high-quality oil. It's exactly the same thing. You're producing this product. It's a very homogeneous product. It doesn't have the contaminants that mineral oil has or mineral diesel has. It is just a very clean, very high cetane, very, very high octane type product, and it's an amazing outcome, because you can, no matter what you do, as long as you put the gas in one end, you'll get clean liquids out the other.
Talk about percentages here. What percentage will be used, say, for gas that goes into a power station to generate electricity, as opposed to making diesel fuel on the other side?
Well, if you've got a gas to liquids plant, so if you've got a large UCG operation that's making the gas from the underground coal, you've committed to a very large gas to liquids plant, which is the plant that makes it into diesel. That's like the size of an oil refinery. So that takes your priority. So really, what you do is you feed most of the gas through that, and about 75–80% of the gas you put through that will turn into a diesel product or a liquids product. There's a percentage of gas left over that you would then feed into the power station. So, it's about somewhere in the 75–80% would go to gas to liquids, and about 20–25% would go to power generation.
Given both the cost savings and also the environmental benefits, I'd imagine that politicians haven't been exactly knocking your doors down because it's so obvious. Politicians obviously miss the obvious. Have they been knocking on your door, or have you had to go to them and explain, look, these are the kind of environmental benefits, these are the kind of cost benefits, and this is the kind of coal we're using, otherwise it would be sitting in the ground doing nothing? Are they open to the argument? Are they on board?
Well, politicians are like human beings. Most human beings. I'm not sure they are humans, but most human beings.
I'll give them the benefit of the doubt.
Give them the benefit of the doubt for the day. Yes, we particularly at federal level. Martin Ferguson, the Minister of Mines and Energy, is a great supporter of Linc and what we're doing in coal to liquids and how we're doing it. And he gets, and he's a big supporter, and he's quite visionary in how he gets it. There are a number of other players inside politics that we've taken to the site, and they get it. Minister in South Australia, Paul Holloway. Again, he's very good and he's been at site, and again a good supporter, and he gets it. And there are not many others. So most people that come to site and see it and join the dots go, it's self-evident. It's a great concept. It has to be part of the energy solution. I guess it's just the ones that don't get there and aren't joining the dots that we need to keep working on to win over.
With the government looking at a fixed CO2 reduction of only, 5% by 2020 at the moment, using this sort of technology is the potential for Australia as a nation to push that number way higher is pretty significant, isn't it?
Well, there's a number of ways. Obviously, if you started to use our gasification process to feed gas-fired turbines, you would drop your, and using some other technology that we have access to, if using gas turbines, you're going to drop the CO2 footprint by 25–35% straight away.
Wow.
If you're using fuel cells in some of those applications, you're dropping it by 85–90%, because there is still some footprint.
Sure.
And then you've got the synthetic fuels production, where the great benefit for that is because Australia's gone past peak oil, so every month, every quarter, every year that goes past, we're importing more oil, and we have to pay for that. We have to physically write the cheque to the overseas countries to buy that oil. So the coal we export, the wheat we export, the iron ore we export, etc. That's all that's going to go is just paying for the oil that we consume and some of the other commodities. But every year that goes past, we are basically just exporting our wealth to pay for the right to drive our cars. Now, if you can produce the oil in this country and retain the wealth in this country by something like what we're doing with gas to liquids, then you don't have to write that cheque. The wealth stays in the country. And
in terms of environment, so if I'm not mistaken, once you put that synthetic diesel fuel in a diesel car and run the car, the emissions are 35% of what they are currently?
That's right, yeah. So again, it's a lower CO2 footprint, and it's not just lower CO2. It's lower particulates, it's lower aromatics, it's zero sulfur. It's amazingly beneficial and far cleaner than current fuel products.
So not only reduce CO2 emissions, but a cleaner atmosphere generally.
Oh, absolutely, and it's a better fuel. You can take synthetic fuels like synthetic oil. It's a better product. So you can put synthetic diesel in your car. And it's got more power, so it's more grunt. It's like a premium diesel,
wow.
And you can just put it straight into your vehicle. There's no mixing. It's not like biodiesel. It's it's not ethanol. It's the malt Scotch or diesel. It's the best product you can get. Makes a lot more sense.
CEO Peter Bond, appreciate your time. Thanks for joining us here at ABN.
Thanks, Brian.